live. So yeah. Right, going live. Yeah. Yeah, right. So we are live now. Yeah, good, very good. So yeah, we'll wait for some time and then we'll.
Yeah, no, that's fine. I'm just going to see if I can put a background up.
Yeah, I can put a background or so. Yeah, that's right. That's fine.
Okay, can you see that background?
Let's see. But you won't be. Will you be visible? Okay. Yeah, we can see the background. Yes, we can see the.
Okay. All right. Okay.
Very good.
It's better than my bookcases.
Right. Yes, absolutely. Okay, good. So we'll be starting in, let's say, 10 minutes or maybe.
Yeah, no, that's fine. I'll just go to the toilet. A comfort break. Okay, I'll be back in a minute.
Yeah,
I'll be back in a minute.
Yeah, right. That's fine. You can mute and also switch off your videos. Right? Yeah, absolutely.
Okay. See you in a minute.
Yeah. Absolutely. Yeah, this is yeah.
Hi, Nigel.
Hi, Bobby. How are you doing?
I'm good. How are you?
Yeah, not so bad. Lunchtime here.
Yeah. Okay. You had your lunch or
No,
before?
I don't have time for lunch.
Oh, okay. So probably we'll let you leave early.
Water.
Okay. We'll start in a few minutes. So
That's
we are
fine.
waiting for some more audiences. Okay.
That's fine.
Yeah.
What's the temperature? What's the weather like?
Well, it's warm now. It's summer. Your summer.
Yeah, it was freezing here. It was -2 when I left the house this morning.
Okay. So we have UK summer now.
Nah, you're probably warmer than the UK summer.
Probably like last summer. That was quite warm.
But you remember, yeah. Global warming.
I think we should start. It's time. So I'll just briefly introduce Professor Nigel Mason. He did his graduation and PhD from University College London. Then he joined University College London as a postdoc under Royal Society fellowships. Then he joined University College London as a lecturer and then later as a reader. After that, he moved to Open University as a professor. He was the Director of Research and Development at Open University. He was also the Dean of Research, Enterprise and Scholarships. He also started a Center of Molecular Sciences at Open University. And in 2018, I think he moved to University of Kent, Canterbury, where he joined as a Professor of Molecular Physics, also Head of School of Physical Sciences. So currently he's at University of Kent. He's been the chair of many multi-million euro projects like Europlanet, ELENA, and so on. If you look at his research, he has published more than 500 papers, have H-index of around 50, with 35 plus PhD students graduated, I guess, and about 20-25 postdocs worked under him. He has collaboration from Japan, India, Korea, all over Europe and South America, I guess, and Americas as well. I personally have contact with him from 2003 onwards. Like 2002, and we met for the first time in 2003, I guess, and then I was with him for 1 year, and then we have been collaborating since then. So we have been in touch with for like say 20 years. Yeah. And he visited India many times. He visited Dhanbad and ISM in 2016, during 16 years, January, during my conference. He gave a talk here, so some of you might be remembering that. So I think probably with that introduction, and then today's talk, as we have already seen, something which is quite important because it's very difficult to communicate with the public, also the policy makers about scientific developments which is required for that particular time period. So it's not an easy task. So hopefully we'll get to know how to actually interact with the public audiences and especially to the policymakers regarding, say, for example, climate change and how do we go about it and so on. So over to you, Nigel. Please go ahead.
Thank you very much, Bobby. Can you see the slides?
Yes. Is it stuck? Yeah, we can see your slide.
Hello?
Yes. Please go ahead. We can see your slides.
Okay. All right, good. Thank you very much. Well, welcome everybody. Good evening in your time and lunchtime here. Thank you, Bobby, for inviting me to give this talk. And as Bobby says, we've known each other for, well, 20 years this year, when he was doing his PhD and visited us for the first time. And we worked in collision physics, electron interactions with molecules. What I'm going to do today, though, is slightly different. Seeing the title of this lecture series, what I'd like to talk about today is the responsibility of all of you in the room and all of us as scientists in how we address the major scientific challenges of the day to different audiences. And audiences can be the general public, it can be politicians, it can be educationists, children, our students. And I'm going to be a little bit controversial because I'm going to put forward ideas that I want you to reflect on. And at the end, after about 40 minutes, we'll have time for discussion. Now, we live at a time where many people believe that we are facing a variety of crises, which have scientific backgrounds. Global warming is obviously one which we live with, perhaps in India with the droughts and everything. You're experiencing it as much as we are, but in Britain, we have the not only the droughts, but we also have the changing cycle of the seasons, and things that used to not be able to grow in Britain do. Some of those are good things. So, for example, for the first time since the Romans, we are growing wine in the south of England, good old British wine. So that hasn't been done for many centuries. But the consequences of global warming are universal. No country, no society is immune to it. And nobody can just say, oh, it's not our problem. And it can't be solved without a global approach. And we've seen in the last 3 years the problems of health and the COVID. Nobody expected it. It took over all of our lives to one degree or another. And the causes of it and how we responded to it, again, had to be done as a global society. Some societies tried, like in China, to basically say, we're not going to have any of it. We're going to close it all down. We're going to make it zero. But as we've seen in the last few months, that wasn't a tolerable strategy. They kept a lid on it for some years. But once it people started to move around and they released the restrictions, we've seen very high cases. Nobody quite knows exactly how many. And again, it just shows that no country is immune to the effects of how it breaks out in another. The next picture is war. And we are living at a time of war. In Europe, we haven't had a major conflict in Europe, but now we do. The Ukrainian conflict is on our doorstep. Many people in Britain used to go to Ukraine for weekends and for holidays. And so it's more physical for them. They can actually sense, they can see the places which they were going to now being bombed. And how do you restrict that? How do you engage with that? And then there are other major crises which are felt to be facing humanity over the next years. Some of those are health, global mental health crisis. Some are the bottom here on energy, again, partly linked to the consequences of the recent conflict, are showing that our assumptions that energy would always be free and easy to have is not true. And that links to climate change as well. As I say, going back to health, the populations are gradually getting older, particularly in more developed Western countries. We are facing a crisis in my children's generation, where for the first time in history, the number of people working will be less than the number of people not working, because the people retiring will be living for longer. And so the people who are actually generating the wealth are going to be a smaller fraction of the population than has ever happened before. But with age becomes problems. As we get older, diseases that perhaps didn't affect us 100, 200 years ago, like Alzheimer's disease, are now more prevalent. And many people, and probably many of us, will probably suffer from that when we're in our 70s, 80s, and even as we might expect now, in our 90s. There is a global food crisis. We have a big population, the population boom or bust. In India, you are due to become the country with the largest population of a country of anywhere in the world, overtaking China in your lifetimes. With that, you need food. Whereas in other countries, in European countries, the population is expected to shrink because families are having fewer children, and therefore the population is actually shrinking. So these are all global crises, and they all have to resolve some of those crises, all of them are felt to have scientific approaches, scientific challenges. So science is expected to solve these problems to some extent. People trust, as we'll see in a moment, science. So we talk about the cure for cancer. Can we cure cancer? Can we cure other diseases like Alzheimer's disease? Do we understand it? Etc. And then we're turning our attention to energy. As we go away from using fossil fuels for global warming, science is expected to come up with the solutions to make more efficient renewable energies, better solar panels, better wind power. Perhaps, and indeed in the paper today, a British politician has stated that he could see fusion energy being effective and operational within 15 years. I don't quite know where he got 15 years from, but they're stating it. We're changing from petrol-driven cars to electric-driven cars. All of these issues, the fusion energy, developing better fuel cells, developing better batteries, developing better cars, developing cures for cancer, all of which are expected to be resolved by us, the scientists. So science is expected to solve the problems. As you can see in the picture here, scientists, if you like, are kind of almost expected to be the new superheroes. We will solve the problems. And government funds science because it expects results from the money it puts in. Governments, no matter which country, expect the scientists to come up with something to solve those problems. So what are our expectations? How do we explain to the government? It's not quite as easy as that we're not really superheroes who can put on a cape, rip it off and fly. The interesting thing is that scientists are generally amongst the most trusted people in the professions in the world. Here is a recent survey, and there are many surveys of this, and it doesn't really matter, as you'll see in a minute, which country of the world you're in. Scientists are again regarded as among some of the most trustworthy people in the world. And as you can see here, they're as trusted as doctors and teachers. You will see the bottom of the list, the politicians. Only 9% in this survey trusted politicians, and 67% didn't trust politicians. And you can see some of the other ones down there, the government ministers, bankers, and so on, journalists, don't come out very well. But scientists are regarded as trustworthy. And the question is, are we as trustworthy as people expect? How do we live up to this expectation of generally being trusted? Because actually, people have, in the last few years with COVID, begun to question the trustworthiness of scientists. And this is because scientists have, in the COVID, been on all our televisions, in all the media, in the face. I'm sure in India, you had exactly the same as we had in Britain or America or anything else, where you had the government scientist coming on to the TV to tell you how to deal with COVID. But that meant that scientists began to become questioned. The objectivity of the scientists. Were they saying what they said because it was true, or were they being influenced by, for example, the government? The government wanted you to do something, so they got to the scientists. Did the scientists say what they believed, or did the scientists say what they thought the government wanted them to say? And were the scientists seen to be caring people? Because life and death decisions were literally being made. And there's a little graph here on the right-hand side. You can see this chart here, which is a sort of plot about how warm, how empathetic the person is against their competence. And you can see on the top right-hand side that teachers and nurses and doctors are felt to not only be very competent and therefore very trustworthy, but on top of that, they're also felt to be very caring. Scientists are, again, as you can see, almost on the extreme right hand of this graph here with engineers. They're believed to be very competent. But they're not seen to be quite as warm or empathetic. That means that scientists may make harsh decisions, but forget about how they affect people. And that's an interesting point of view. And you'll see other people, scientists, have about the same degree of warmth as a cashier or an accountant. That's what people kind of thought on this survey. And then on the left-hand side here, you see what do they think that scientists are trustworthy about? How typically do you provide accurate information? Well, you can see there, interesting ones. It's believed that scientists are actually talking about the origin of the universe. I work in that area. And we believe that basically we're likely to tell you the truth about the origins of the universe. We're likely to tell you the truth about renewable energy. In fact, interestingly, this may not be entirely true in every nation, in America, for example, but even so, the trust is pretty high on saying on evolution. But as you go down, look at the bottom here, the flu pandemic, the drugs, and the pesticides. They don't necessarily believe that scientists tell you the truth all the time. Why is that, and what does that mean? Now, I think if you want to understand how scientists work and how we think, we have to think about why we become scientists. And everybody in this room who's a scientist can be thinking about that now. Why did you become a scientist? Why did you choose it for your career? And there are, again, many surveys on this. And generally, the key view is that scientists are curious. They like to solve problems. As I said, one of the scientists put it, I love puzzles. And to me, science is the ultimate puzzle. We do it because we like problems. And we like to work our way through those problems and come up with an answer. Interestingly, very few surveys of scientists state that they do it for money. It's not the most highly motivating factor. And this is, again, is a challenge because obviously much of the science that we do leads to products. It leads to things that we want to think are good for humanity and mankind and sell it. But the scientist who develops it often doesn't do it because they ultimately want to make money and become a billionaire. They do it because they want to solve a problem and get something to work. Other people, entrepreneurs, may then take over that idea and commercialize it. But despite attempts by governments and everybody else to get, if you like, academic scientists, university scientists, to think about making money, it isn't generally what gets us up in the morning and gets us into the laboratory or onto the computer. And on the left-hand side here, you'll see a kind of survey, key experiences, decision making in sciences. And you can see the top one here, 32% said it was the intellectual challenge. It was the love of science or nature. 27% go into science because they work in a scientific background. The scientific community literally fosters and gives birth to the next generation of scientists. A lot of people do science because it's in their family. And they get switched on because they study science. And as soon as they study science, they get interested in more in it. You'll see at the bottom of the list there is to make a difference, to contribute to society. Only 8% in this survey said that. Now that's interesting because I think if you ask scientists, you ask them the question, do you want your work to contribute to society? Most scientists will blasé say, yes, of course I do. Of course I do. But when asked to list the things that make them do science, generally what most of the surveys show is that scientists don't really do it to change the world. They do it because it's personal. They like the style of science. They like the way of thinking of science, and they want to solve problems themselves. And that's an interesting factor, which perhaps is also going to be increasingly linked into the trustworthiness of scientists. Why do we do it? Well, we do it because we're interested, not necessarily because we want to do it for the greater benefit of mankind. If you ask the same sort of question to, say, a nurse or a doctor, then you would probably get, and the public would expect us to say, well, Of course, I've become a nurse, or I've become a doctor, or I've become a vet because I want to look after people or animals. So if that's the background of the scientists that we have, we then have to ask ourselves, what are the responsibilities for the scientists, the delivery, and the conduct of the research that we do? We've established that scientists want to solve problems. But is solving any problem, is obtaining any type of knowledge acceptable? So if you're working in genome, changing the genome, if you're looking at disease, if you're looking at weapons, making military weapons, each of these you can solve as a problem. But is anything acceptable? It's just the quest for knowledge so overriding that it doesn't matter what the consequences are. And as one Nobel Prize winner put it, it isn't the feeling in many scientists is it's not the knowledge itself that's dangerous. There's no harm in finding knowledge. What is dangerous is how it is used. And then the question is, how does the scientist control, and the scientists control, how their knowledge is used? And should they worry about that when they're doing their science in trying to solve these problems? So the next question is, are scientists led by funding? Well, I'm sure anybody working in the university and with heads of department sitting in a room, Bobby, you will always be asked, what are you doing to fund your research? How are you going to attract money to the university to do this research? Now, the question is, if you take money for research and you just have to raise this, what's your responsibility for ensuring that the need for the funding doesn't influence the research that you do? So the example, for example, of a tobacco industry spending lots of money, giving research groups lots of money. If you are a person receiving money from a tobacco company or any other vested interest, and you conduct your research and you get a result which your sponsor is not going to possibly like because it might influence, it might say that their product they're making is dangerous or it's not working as well as they did. So for example, you build an electric car, you build a battery for an electric car, you spend lots of money on the design of it, and then when you actually test it out, you find that it's actually not very efficient. What do you do? Do you tell the company? Do you tell the person funding you that? And if they say, oh yeah, I don't really want to spread that in your story too much. It's not really good for our profits. It's not good for the sales, right? Let's keep that quiet. What do you do? So there is a great feeling among some of the global warming deniers that essentially the scientists are doing this, are claiming this because there's so much money in it that it will just generate more money. And they're almost claiming that they have claimed, indeed, in America, that scientists are almost kind of being fraudulent because they're just trying to say it's a problem so they can get more money to solve a problem that doesn't exist. Now, this brings you into the whole area of conspiracy theories and everything else. Nonetheless, is taking money from anybody acceptable? And what about, shall we say, rather governments that perhaps whose politics and policies perhaps you don't agree with? Should you just take the money because they'll fund you your postdoc or your students, or they'll give you some money for the lab? And let's just forget the politics. And this really brings us to the point about science and government. The major source of funding anywhere in the world is government. But government's political. Governments are, particularly when they're elected, and even when not elected, they are there with their own agenda. So they may prefer or even want you to have a specific income outcome. They may decide that, they may tell you, but you're doing this research, it'd be really useful to be able to say that this country has X or this country has Y, or this problem which has been raised maybe by the opposition. If you can provide me evidence that it's not really a problem, I'd be really grateful. So how do you as a scientist address this? So this brings us to science and politics. Albert Einstein said politics is more difficult than physics, and he was absolutely right. In the center here, it's quite nice as a cartoon. You've got the scientists exploring a graph, and you've got the politicians exploring another graph called an opinion poll. And then down the end here, you've got the scientists who's given the information, and then the agency misinforms what it is. And increasingly, what you're finding is that trust in science is becoming a bit of a partisan issue. I'm afraid I haven't got a figure here for India. Maybe you know that. But you can see here that in recent years, 2019 and then subsequently in the pandemic, different parts of the political agenda, left and right, are responding to the trust of scientists in a different way. Generally, what you're seeing here is sometimes on the right, they have less trust in scientists than on the left. That's not always the case. It does depend where you are. It depends where your government is. But how do you avoid becoming part of this partisan issue? If you have one party that wants to do environmental change and is campaigning on it and is being very righteous and saying, yeah, vote for us, we're going to save the planet and the next, your children of the next generation, we are the good party. And then the other party is saying, look, don't listen to these guys. A, they won't do it. And B, do you realize how much is this going to cost? It's easy for them to say this, they're going to do all this, but you're not, the fuel price is going to go up 3 times. You're not, you're not going to be able to afford your fuel bill. We're going to take away your wood burner. We're going to increase the cost of a car by putting extra tax on it to make greener. The science doesn't back it up. All these things they say isn't really true, and it's just going to cost you lots of money. So you immediately become this partisan issue. So the question is, well, how do scientists engage in that? How do scientists get involved in politics? Indeed, should scientists get involved in politics? And this is a question, I think, which I think all of us have to address. And the more senior you are, and it doesn't matter what position you have, it might be head of a university, it might be a head of a research team, which is talking to government ministers. It might be working in industry where you're having to talk to the state because you want to build a new factory somewhere. Politics and science does go together, and the more senior you are, the more you need to think about it. Now, generally, scientists as a whole don't really like to get involved in politics. Indeed, you can argue that one of the biggest problems, particularly in the democratic world, is the fact that very few of our elected politicians come from a science background. So they don't understand science. And I know this from talking to many of my members of the European Parliament and members of the British Parliament. You can't try to explain to them even what many people in the room as scientists would think is quite basic science. You generally have people who don't come from a scientific background at all. They can't appreciate some of the subtleties of the science. So you've got 2 options. You could say, yeah, I know all this stuff. I mean, I don't want to get involved with this. I want to just, I'll just get in my lab and I'll do my work and so on. All this political stuff, I'll leave that to others. I contend that you should not do that. And that scientists as a whole have a duty to engage in political debate, because politics and science and the consequences and the decisions that are being made in politics are largely going to be based in the next decades on an understanding and an appreciation of the science that we do. So scientists cannot just walk away. We have to engage with the politics. So here's something I found from India recently. You may have seen these leaflets during the COVID, right? Now, what's in these messages? Okay. So this was about telling people to get the vaccine. And in every country, there were people who were contracting that, who were saying vaccines are bad, they're going to kill you, or they're going to take over your brain, or etc. So what did governments do? Governments generally felt, okay, we need to sell the story of the vaccine. We need to get the vaccine out there. Lots of dead people is not going to be good for us being re-elected. And if we are seen as a government not to take control of this, there's going to be a problem. But if we go out and tell the people to do this, they won't necessarily listen to us. Remember that first level of the politicians is right at the bottom. So we'll go and get the scientists. We'll bring the scientists on board because people trust the scientists. So let's get the scientist in there. And so you get things like this. India's top medical authorities and scientists have tested the vaccines. They are safe. They are effective. And here's the slogan, tested and approved by leading scientists. COVID vaccines are safe and effective. The governments all over the world were trying to explain to people that, yes, there is a problem. There is people are going to die from this, but we have a solution. But to get people to accept it, we couldn't just rely on the politicians going on and saying it. We had to get the scientists to come on and say it. So you've got to join the scientific debate. Now, here is a sort of typical argument between the two people, right? You've got an interview, you've gone on television or you're on the radio, okay? And in front of you, you've got a journalist, you've got somebody from the media, or you've got a politician, okay, with you. Now, the debate begins about an issue, okay? So the journalist says, let's talk about the problems of global warming. And they say, now, there are two views. There are two sides to this argument. Okay, the people who believe in global warming and the people who don't believe in global warming. And the journalist and the politician may often take the view that there's one or the other. The media will say, okay, you know, we need to be fair. We're going to have the two sides. What does the scientist do? The scientist will often reply, well, actually, there aren't two sides in this argument. There are the facts. Right? There are the facts. And the other side may dispute the facts, but there are the facts. This is not a 50-50 either opinion, you know. So the politician, but isn't you're saying, you know, there's an absolute truth here, but that isn't true. Can you be 100% sure? Can you be 100% sure that what you're telling me has no risk, zero risk? Now, a scientist will reply, oh yeah, well, nothing's 100%. You can never be 100% sure. No data is given to give you a 100% answer on anything. But science is about the evidence, and the balance of the evidence is. And as soon as they say that, the politician media comes back and says, you say then, so you agree? There isn't you're not 100% sure. You could be wrong. The other side, the other view could be right. So how do you cope with that when you're having the scientific debate? And let's look at some examples, which are frankly lies, right? The world is flat. The world is not flat. Okay? So you're going on television to debate with somebody who says the world's flat. Nobody went to the moon. Right? The world is only 6,000 years old. I'm sorry, I'm going to give you the last one for India. Astrology is a science. Frankly, all of these are untruths. The world is not flat. We did go to the moon. We know the world is more than 6,000 years old. And there is no scientific evidence or any scientific methodology that we have ever applied that says that looking at your star sign will actually tell you what you're going to happen to you tomorrow. It doesn't work. How do you debate those? Because every single one of those will have a very strong advocate for the other side. And the journalist or the media is going to say, oh, well, you know, how do you explain this, that, and the other? So failing to confront lies is both dangerous and unethical. And in America, this used to be called the snake oil salesman. The person used to go around all the towns in the far west with a bottle of snake oil, saying, oh, this will solve all your illnesses. It will get rid of your rheumatism. It will enable you to have more children. It would increase your brain dependence. You know, you'll be brighter, everything else. It's rubbish. The miracle cure. Yet we still have many miracle cures. And we saw that during the COVID pandemic. Some of them were just dangerous for people. How do you confront those? What's your responsibility as a scientist if you hear somebody in your village or your town telling these lies? Similarly, If there is false science, like, for example, the old ideas that, you know, intelligence was done by race or whatever, the Nazi ideas, which were being peddled because of an ideology. How do you stand up for that? What is your responsibility as a scientist to say this, you know, there is no evidence that women are not as clever as men in mathematics or any subject. There's no evidence. But people will still say, oh yeah, well, you know, I saw a report by somebody that said, you know, no, right? What's your responsibility for that? So to do with that, you have to think about, why do people lie? Because when you get in front of somebody who's peddling some of this, they will be very persuasive. You see that in some of the politics today. And I can name some that you probably know, some in the current war, where people just, the politicians just blatantly lie. So why do people lie? Sometimes because they get excited by it, it's an excitement, they want to. It's easy to lie because basically it means that you can just, somebody is being aggressive towards you, so you just lie to appease them or to pacify them. Sometimes if you lie, you might get rewarded. If the government wants you to say something, or the industry, or somebody wants you to give some false information, and you support them in that, even though you know it's not true, you might get a reward, you might get promoted. If you don't, on the other hand, if you might be threatened. You might be threatened if you don't go along with the lie, and to go along with the lie. Sometimes it just may be the person wants attention. I think we all know people who are kind of attention seeking. It's well known. There are various symptoms in the social sciences. Sometimes people lie to get sympathy. You know, oh, you know, I'm not well. You know, I've got, you know, I've just been to the doctor, and you know, it's potentially, you know, I'm being checked out for cancer. You know, oh God, I'm so sorry. You know, I really feel sorry for you. Yeah, I know. That's why I haven't been able to do my work properly for a while. You know, God was going on in my mind, right? And some people do just to trust. So how do you deal with somebody who's lying to you? How do you deal with somebody, particularly if it's lying in science, where you know the facts? Well, the first thing is you can't lose your temper, because that automatically makes you lose the argument anyway. You've got to expect that the other person is going to lie and is going to deny any of the facts that you put forward. So you can't debate the facts with somebody. You just have to state them. You can't qualify the facts. As soon as you get into a discussion of, well, you know, can you interpret it a different way or whatever? No, if you know the scientific facts of a scientific fact, you've got to stick with it, and you need to keep to your message. So when you see something controversial, you have to think about how you deal with that controversy. And in the scientific area, we have the controversy sometimes because the research that is published and the papers that are published maybe haven't been reviewed and the data hasn't been analysed properly by others. And this is why we have what we all are taught, and all scientists trust, which is this idea of scientific method, which goes right back to you know, in Europe, the Reformation, the idea that you make an observation, you question about that observation, you build an hypothesis, you then develop an experiment, and experiments can be modeling theory as much as things. So experiment isn't just doing hands-on experiments. That experiment tests the hypothesis, and then you come to a conclusion and you get a result. And then that result is published. And that published paper is peer-reviewed. Okay. Now, sometimes what you find is that papers are published which overhype the results. I forget how many times, but I guess it's dozens, that I have heard, we have got a cure for cancer. Like, this will lead to a cure for cancer. It isn't, we haven't got anything that leads to a cure for cancer. There's nothing magic drug that you can take that's going to cure every cancer. But the media will always be pushing for that. The media wants the story. They don't want your piece of research to say, well, you know, we've made an incremental increase. You know, we've learned a little bit of useful information that might help us in 20 years to understand cancer in rats. They're not going to publish that. They're not interested in it. We had a story a couple of years ago, last year, about the possibility of a molecule being found in space, in the Venusian atmosphere, Earth's atmosphere, which was positive, which might be a signature for life. It was very controversial because actually the data, the quality of the data, was perhaps, still not 100% resolved. More experiments, more analysis had to be done. So, but it got out, and the team that announced it were then kind of trapped because the media said, "Oh yeah, you found it. We found life on Venus." Of course, they said, "No, we hadn't." But the story runs and runs. So there's always a risk that when you publish your results, you want to say it's more important than it is, because after all, if you just say, "Oh, I've just done a little bit here, it's not very interesting," you're probably not going to get another grant. Whereas if you say, "I've made a really big breakthrough," then you're more likely to persuade funders to give you more money. And also, we all I think we've made a significant breakthrough. We like the prestige factor. That's why we have peer review. And that is why peer review is so important. My students will say, "The paper's, I've just seen this published paper." I said, "Where was it?" "Archive." I said, "It's not published then." "Oh, it's on archive." They said, "It hasn't been peer reviewed." We put our papers on archive before it's been peer reviewed. Does not mean that is that paper. Referees generally, we've all been there. They will find something and question some of the things that we've presented, and they may be right. So peer review is vital because it's also scientists policing other scientists. That's where the trust comes. That if one of your community publishes some bad data, you know it, right? And the question is, what do you do when you know that? So what are your responsibilities? Is it just somebody else's problem? Or it's not my business? And my argument today, and I want you to think about this at the end of the day, is that science is a global enterprise. Scientists are a truly global community. We all work together across the world. And therefore, this community, this international, this global community, has a responsibility to regulate itself. And the American society has a statement on this, and it links scientific freedom and scientific responsibility. It says, scientific freedom is the freedom to engage in scientific inquiry, to pursue and apply knowledge and communicate openly. But this freedom is inextricably linked to an exercise in accordance with scientific responsibility. Scientific responsibility is the duty to conduct and apply science with integrity, in the interest of humanity, in the spirit of pursuit of the environment with respect for human rights. That was issued in 2017. You can play around with words, but I think the critical issue is that scientists, we have a freedom generally to explore the world and things. As we do that, we have a responsibility for how we report our results and how we police our own community. So I contend that we have a duty of community and our duty as scientists. And therefore, that we need a charter that says this, a kind of Hippocratic oath for scientists. If you are a doctor in the UK, and I imagine in most other countries in the world, when you graduate and become a doctor, you are expected to read and swear to the Hippocratic oath. And these are the terms of the Hippocratic oath for medicine. And they were established in 1964. They were written down in 1964, and they're used in nearly all medical schools today. And they basically say what the responsibility of a doctor is. Okay. And you've got things in there. I remember there's the art in science, as well as the science. You're expected to show warmth and sympathy as understanding. You will not be ashamed to say you know not, nor I will fail to call in my colleagues when the skills of the others are needed. If you can't stop the bleeding of an artery, you call in the guy next to you who can. You remember you're talking about a human being and you're remembering your responsibilities. And most of all, your responsibility is to save life. So I contend by saying that our Hippocratic oath, our concordat, the scientists, should be the following. We must call out false data and confront lies. It might be difficult to us. It might be a risk in some countries to do that. But scientists need to be brave enough and confident enough and unite together to call out false data and confront lies, not let somebody think somebody else is going to do it. We need to confront those in our community who misuse the scientific data. We need to expel from our community those who transgress. We need to inform the public of science knowledge. We need to educate the public in the way that science is conducted so that they can understand the debate of science and this problem of it's 100%. Most of all, as people who work in universities and as academics and as people who have responsibilities and teach and lecture to new students coming in the same way as medical students are told by the people who teach them the Hippocratic Oath and what ethics and morals and contributions they're supposed to make, I would say that we have a duty as scientists working in universities and educating the next generation to also talk to them about scientific method and the ethics by which we work. Thank you. I hope that has been a little bit of a thought-provoking talk, and I will welcome questions or comments.
I think questions. Anyone? If you have any question, you can come forward and then ask the question here because the microphone is.
They're all thinking now.
Pardon?
I hope they are all thinking now. Go home tonight and just think on what this has been about and reflect and see if what I've said you think is correct or not, but just think about it. That's the idea of today's talk. But I will take any comments or questions. Please do.
Comments or any questions? Yeah. Yeah.
So Professor Nigel, it is a very nice talk. What do you see about the commercialization of science? What is your view?
Yes. There's nothing wrong with the commercialization of science. I mean, what is the point of having knowledge if you can't expand it? I mean, what's the point of inventing a drug that can cure somebody if you can't then actually commercialize it? What's the point of designing a better car engine which is cleaner if you can't sell it? There's nothing wrong in commercializing science, and indeed, if you go right back to the earliest scientists, they were hired by kings and so on to use that knowledge for example, I don't know, making better steel for weapons or for designing better bridges or whatever. There's no wrong with that. I mean, that's the commercialization aspect. As I said, a large minority of scientists don't go into science to make money and commercialize things. And I think probably the skills that we have are probably not the same as you need for deciding how to take something to market and how to advertise it and how to determine what the price structure and so on is. And that's a slightly different. So some people will move over to that naturally. Other people will come in from a business. A lot of people do business degrees and everything else. There's not a bad thing, and when people seem to say, "Oh yeah, but all these wicked capitalists are going to cause problems." I think we have to think very carefully about, there's nothing wrong in the commercializing things, because it's the only way you're going to get it to market. And states generally aren't very good at doing it. I mean, dictatorships have never been particularly good at developing a market for goods. They're generally politicians. If politicians were to decide what you would have, there's a famous old story, why do we have a knife, a fork, and a spoon? Okay. if you had a political cabinet deciding, well, we've got to decide, guys. Do we want a knife and a fork? Do we want a spoon and a fork? Do we want a spoon and a knife? Because we can only afford centralized planning. We can only afford to have a factory that builds two of the three. Now, a commercial person will say, "No, hang on. It's all different. Somebody, if I'm going to, what am I going to use this knife and fork for? There's a market in whatever I do, right? So if I'm going to be making meat, I better have a knife, right? If I'm going to have a jelly, I probably would find that rather hard to eat without a spoon. So the scientists will invent these things, and then the commercialized people will decide how to apply it to the market. And there is links between them, but there's nothing wrong with commercialization. I think we would not have the living standards we have today. We would not have got rid of smallpox predominantly if we hadn't linked together science with the commercialization. And I don't believe that inherently anybody who goes into trying to make money and profit is somehow not a nice person, which in some societies and some people you hear that. I think that's just rubbish.
So thank you, Nigel. So another question is that nowadays there is a very unnecessary race for publication and publicity in scientific communication. So do you think that is a bad implication for scientific endeavor in the future?
Are you asking that do we have a duty to do public engagement in science communication? Is that what you're asking?
Well, yeah, I think he was asking like the race to publish more papers.
The race to publish more papers. Yeah. Well, as I say, I think who's deciding that race?
Well, probably the institute regarding your promotion for say or your career development.
Yeah. Okay. So do you just accept that, or do you, as when you get into a position of power, say actually this doesn't work? It's like H-index, right? Would you say if you're trying to appoint a member of staff, let's just look at their H-index, right? If they have an H-index of 52, and that's the top one, I've got 6 candidates. I've got an H-index of 52, and I've got an H-index of 24. Oh, let's not have no interviews. Let's not do any of that. Just appoint the person with 52. It's meaningless because every area of science, the H-index is dependent upon the area of science you're in. If you are a mathematician, you will not have a high H-index in pure mathematics. It takes much longer to publish a paper in pure mathematics than it does in many other areas. So the community has the right to talk sense. And if you're on when these are being raised and you're discussing it with your institution, think about it. Who's telling us to do this? Who's telling us to do that? And if somebody says, okay, I want to increase my number of publications, so I'm going to take this paper and I'm going to cut it into 5 sections. I'm going to publish one on elastic scattering of electrons, one on ionization of electrons, one on dissociation of the molecule, and one on vibrational excitation. So I've got one molecule, and I'm looking at the electron excitation of this molecule, but I'm going to divide it up, so I'm going to get 4 papers because it's going to make my publication record look right. I think Bobby and I would say if we saw that, I'm sorry, this isn't, if you're going to do this, we're not going to let you publish it like that, right? You should tell your student no. And you should, and if you see somebody doing that, you should say, no. When it comes into the referee, this is where we have to police our own, because we have to say no. And you also, right at the beginning, have to tell the students who are doing this is not the way you do it. But you're absolutely right that this thing about H-index and number of publications. There are, it's not just weight. It's like sport, right? If you're playing cricket, you don't just say that, oh, well, I get the fastest bowler. He might be very fast. He may not be terribly accurate and anything else. So would you just have, I just want the fastest bowler? Or would you like one who actually knows where to put the ball? So it's the same in science. You know, don't be persuaded by numbers and things, because they all mean something completely different. The community knows that. But if the community starts to play its own game, if the community starts to say, oh, each index is very important, we've all got to follow it slavishly, then I'm afraid I think the community is at fault, because it's setting it's causing itself its own problem.
Okay, thank you. Any other question? Yeah.
Hi, can you hear me?
Yes.
Yeah. So many times when a scientist develops something or invents something, it is always for the service to the mankind, right? But many times we have observed that it is also used for the destruction of the mankind. So what is your opinion regarding that kind of inventions?
Well, I mean, that is the classic dilemma that you know, if you invent, you can invent something for good, but it can, you know, often it can be used for ill. Now, the question you have to ask yourself as a scientist is, I mean, you know, this comes back to the question I said: is any information or any data being used? So let's take an example. In the health sector, I can develop a screening technology that will tell you whether you are likely to get breast cancer or pancreatic cancer, that you have a high probability. So women who have a trait and know that they have a high probability of getting breast cancer, I've done a screen, I can tell you you're at risk. Now, I think we would probably say, oh yeah, that's good, because they can have an operation, they can remove the breasts, like Jodie did, American film actress. That's good. And we'd think that's a very positive thing. But on the other hand, if you're now an insurance company, and the insurance company has that information, and they say, oh yeah, you know, oh, you want to take out a mortgage for 35 years. Yeah, chances of living that long, you know, a bit worried about you, you know, I'll charge you more. So how do you balance those? You can see it from both sides. From the individual, I want to minimize my risk. For the person doing the insurance, they've got to minimize the risk of the money they're giving out. So information can be used in many different ways. I think the job of the scientist is to think about the consequences and mitigate the problems and so on. So you might say to the insurance person, yeah, just because you've got this piece of information, but actually, you know, there are loads of other factors that might make them not survive 35 years, right? You know, they're a fighter pilot and there's a war on. So probably you're going to not insure them because of that, not because they've got some possibility of a disease. You have to quantify these things. In building, that's the whole problem in the health sector. In the defense sector, well, people have to work in the health sector as good jobs. Now you have to make your decision of whether you think, you know, working in the health sector is good or the defense sector is good or bad. If you're building and designing a system to shoot down missiles to avoid them coming in and slamming in and killing civilians and blowing up hospitals, that might be positive. But of course, those missiles, that system could then be used to attack the other side. That's a bad thing. These are the consequences that we have. So scientists have to make those judgments and merits. But I think the important thing is, if they see that their science is being used in a bad way, in a way that's uninterpreted. So somebody, for example, is developing something deliberately to kill people, then you perhaps need to speak out and say it. But it's an inevitable question of science. Knowledge can be used good or bad.
Thank you. Anyone else? Yeah, please.
Hello, Professor. I actually, my question might stray a little away from the talk. My question was, since AI is all the rage, and we're also beginning to train different models to actually conduct research. What should we as scientists think about this? Since you've mentioned in the talk that most of the scientists become scientists because of their curiosity, and AI like using AI in research would be efficient in helping the mankind. So how do we balance out our curiosity and actually getting stuff done?
That's a very good question, because as you're right, we're living in the data age. We have far more data now than about everything. So you can apply AI to questions like trying to understand the formation of the universe. And that AI data is probably not going to cause any harm to society. It might not work. I mean, there's a fascination at the moment to try and use artificial intelligence to produce atomic and molecular data, an area that Bobby and I work in. Do I believe those numbers? Not necessarily. I don't believe that AI, is going to be as good as an experiment. On the other hand, I realize that for, say, something like the JWST telescope, I need so much information. It's impossible to think it can be done by experiment or even by models. You need to generate a lot of data. I think, again, the responsibility of people for something like AI is to think carefully about what the consequences are, and are those consequences valid? So if you write bids, I don't know what they do in India, but if you write them in Europe, if you mention the word artificial intelligence, you have to open up another box. It used to be like working with animals. You've now got to fill in another thing that you're going to show you're responsible for the animals. For AI on humans, you've got to do the same thing. And I think the responsibility of the AI scientist is not to get blinded and say that AI will solve all your problems, but actually to make sure that the consequences and the data derived from the AI is benchmarked and tested. And there's a danger there that if you are so fixated by the fact that the AI is your thing or machine learning is your thing, you'll believe the data because you want to believe the data. Whereas reality, you need to think, okay, how do I check? Because maybe the data I'm going to do may have an unexpected consequence. So I'll give you an example, again, something that Bobby and I work in. You look at electron scattering cross-sections. I always used to say getting an electron scattering cross-section wrong, by 20, 30%. Probably, okay, it was acceptable. List where nobody died from a wrong cross-section. It's not true anymore. We use ion beam therapy, for example, to decide how much radiation dose to put into the patient to kill the tumors. That model relies on basic atomic and molecular collision data and numbers to calculate the dose that the patient needs. So if you use AI to produce a whole set of cross sections and they're all out by orders of magnitude, and you use those to determine whether the cancer, the radiation dose, you could kill the patient either by over or underdosing them. So you need to be sure that the machine learning methodology and the AI methodology is producing data that's reliable. And you need to do something called sensitivity analysis. You need to know how sensitive that is to whatever methodology you're using. So I think AI has a huge advantage moving ahead, because with the number of data sets that we've got, it can tackle problems it's impossible for us to do otherwise. But at the same time, the responsibility of the scientists doing it is to actually not believe that because their model and their AI system, they want to believe it gives everything. To always be responsible enough to think, how do I check it? How do I make sure that what I'm doing here is giving me the right answer? And you need to build in some checks, and we can always do that.
Thank you. Anyone else? So if there is no question further, I guess that's it. Thank you very much once again, Nigel.
My pleasure. I hope, as I say, I hope today, if you go away from anything from this lecture today and you're all scientists in the room, I'd like you just to reflect a little bit about your responsibility of scientists, yes, and how you address it, and also how you teach it. Because yes, if you're in the lecture, if you're university lecturers and you're going to do that, you will teach the next generation how science should be done. And I think that's the consequence I would like you to think of.
Yeah, right. So thank you very much. Thanks once again.
My pleasure. I look forward to being over in India probably next year and coming to see you in person.
Yeah, you're supposed to be here in January, right?
I know. Unfortunately, I've got other problems at the moment, including the world's largest ever space bid. So, yeah, no, fine. See you soon. Take care.
Yeah,
good evening, everybody. Have a good evening. And go and talk about it over tea or whatever.
Okay. Thank you very much. Bye.
Bye. I'll leave now. I'll cut now. Yeah. Okay.
Bye.